Welcome to Chapter 4. In this chapter, we will talk about solving nonlinear equations. And these are also related in many financial problems. We will see applications of these techniques that we discuss in this chapter. So let's start with a common problem in mathematics, which is the so-called root finding problem. So if we have a polynomial function, then our root finding problem can be done in MATLAB more easily. So there's a built-in function called as the roots, and this function can be used by just inputting the coefficients starting with the highest order term to the lowest order term. And you can see that the highest order term in this polynomial is x to the 4, and the coefficient is 1. So you start with 1, and then you have coefficient 3, and now minus 2, and there is no x term here, so you put a 0, and then the last term is 4. So if you type the coefficients of your polynomial starting from the highest order term, MATLAB's built-in function can be used to obtain the roots of this function. Basically, that gives you the f of r equals to 0. And you can see some examples of this here. In another example, roots 1 and minus 1, this corresponds to the polynomial x minus 1, and the root finding means basically x minus 1 equals to 0, so we are looking for this x value. Alternatively, we can define our own functions, not necessarily polynomials. So you can see I can define my function by using this add operator in MATLAB, and then I can use this built-in function f0. You need to pass in the user-defined function, and also you need an initial value to start the algorithm. And again, this is a useful built-in function in MATLAB, which we will use in some of the financial applications. But we will see also two fundamental algorithms in this chapter, which are basically the bisection method, the first one, and the second one will be the Newton's algorithm. So these are very fundamental and for a long time used by scientists for finding the roots of different equations. So basically the idea in the bisection method is quite simple. If there is a root of a function f on the interval a to b, then f of a times f of b must be negative. In other words, there must be a change in the sign of this function if there's a root in this interval. Okay. So whenever we notice the sign changes in a particular interval, we will narrow down and continue to search the interval by taking a cut from the midpoint of this interval and continue the same process of checking the signs and trying to get closer and closer to the root of the function. So we can explain this with a figure. It will be much easier. So suppose you have a function f of x like this, and you start to search, you want to search the root in this interval a to b. So what you need to do is take the cut at the midpoint, and we will evaluate whether there's a change in the sign on the left half or on the right half. So you can see that on the right side, f of midpoint and f of b, they have the same sign. So that means there is no root in this area. So we will narrow down our search to the first half, and you can see that there's a change of sign in this area. So that means you need to continue to take another midpoint and check whether the change of sign is on the first or the second half of this smaller region. And we can notice that the change of sign is going to be in this half. So we will continue to take our midpoints until we are satisfying some stopping criteria that we'll introduce just in the next few slides. So this is the main idea in the bisection algorithm, and the next thing is trying to implement this and try to code this in MATLAB.